G'day, I'm Nick Clements from YourQS and welcome to our podcast, Beyond the Guesstimate, where we explore the concept of cost-informing design. I joined the building industry back in 1993 and pretty much ever since then I've been frustrated about the industry and how it performs and how inefficient it is and how many opportunities there are for us to do better. And so in this podcast, I'm exploring different things, talking to different people around that sort of broad theme of cost-informing design. I take a very, very broad view of all of those aspects of it. So a broad view of cost, a broad view of design, and a broad view of informing. So basically just follow ideas and things that interest me and people that interest me, and I think will be of interest to people like you that are watching this podcast. So today's theme is going to be around innovation. So just sort of giving my thoughts a little bit. So we're focused on residential construction. So most of my thinking and works around that. If you look at innovation and look at the sort of industry, the businesses that are involved in our industry sector, in residential construction, about 50% of it is labour. So that's your tradesmen, so builders, plumbers, electricians, the labour going into making frames and trusses, the labour going into making windows, all that sort of thing. So 50% is labour. About 10 to 15% is professional services, so people like us, architects, councils, all of those sort of costs. And then the other chunk is product suppliers. So they're an important part of the mix that makes a building work. So the people that make and provide products that go into the buildings. If you look at what those organisations are, most of them are pretty small organisations. So most of the service businesses like us are pretty small. Typically the builders are pretty small. The architects and designers are typically pretty small. So when it comes to innovation, it's pretty hard for small businesses like us to have a really big impact on the industry. We really look a lot, and it's sort of something I've realised as I was putting this one together, that we really rely a lot on the supply sector to bring innovation to our industry, for a big part because they're typically bigger businesses. So if you're making a particular product or making a range of products, you're going to be a reasonably large organisation or a very big organisation. So I've worked for a couple of industry suppliers over my time, Carter Harvey and New Zealand Steel, and they're both very big corporates. So a big chunk of that supply side is dominated by some really big players. And when it comes to innovation, those guys can do some stuff that smaller businesses can't. So I know one of the things I was involved with was developing the LVL plant in Whangarei. And that was like $150 million investment. So those big guys can do that sort of stuff. What they're not so good at is all of the incremental improvements that happen and all the incremental bits of innovation. And you could almost say that YourQS sort of came out of one of those. So I started on this idea, started on this journey when I was at Carter Harvey. But the problem is with these big corporates is little innovative things don't really fit that well. And there's too much politics. The expectation for returns from the innovation tends to be really short, so it's really hard to make it work. I know in my time at Carter Holt, we had a lot of different parts of the business that were trying to innovate. We had a lot of businesses doing what they called remanufacturing, so we were finger joining timber, making mouldings, making weatherboards, making glue laminated products, and pretty much all of those, as far as I know, I've been out of there a while, have pretty much gone by the wayside, and they're just a machine that produces lots of structural timber and a bit of LVL. And so we're really looking at smaller organisations within that part of the industry, so bigger than builders, bigger than my sort of organisation that are able to bring sort of innovation to our industry. And today we've got John Woodman from Prolam, who I think is one of those businesses that they've really founded themselves on innovation, taken over some of these things that the big corporates like Carter Holt Harvey have dropped, and starting to bring new products and new ideas to the market. And one of the big challenges they've got is being smaller, is getting awareness in the market of what they're doing and making sure the whole supply chain understands what it is they're trying to do with their products. And that was sort of one of the things that got me into QSing, was when we were working on some innovative ideas at Carter Holt Harvey, the traditional QSing processes weren't really sensitive enough to pick up the sort of details that we were looking to try and bring to the building process. And so for us to convince people to change the way they were doing things without having some sort of good information behind how they worked and understanding of the cost implications of them was pretty challenging. So we've actually been doing a bit of work with companies like Prolam and a few others across the industry, helping them understand where their products fit in the competitive landscape against the other systems, and helping provide them with information that they can use as part of their communication of what they're up to. So it's going to be an interesting discussion today. I'm quite looking forward to learning more about John's background and just talking about some of the stuff they're up to. So welcome, John, and thanks for coming along.
No, thanks for having me along, and glad to be part of this podcast, and hope we can make something interesting out of it and something that the listeners really enjoy.
Fingers crossed.
Yeah.
And it's welcome to the wild weather in Auckland. So it's I guess depending on when you're watching this, is one of these days where it's going to be really bad, and we're all doubting whether John's got to fly back to Motueka. I've got to make it across the city. We're both wondering whether we're going to be able to do it or not later on. So hopefully you don't get too much background noise, and it's all good. So John, tell us a little bit. So where did Prolam come from? How did you get into the timber industry?
Yeah, I guess it goes back to my upbringing. My father was a builder. My grandpa was a bridge engineer. So grew up with building timber all my life and engineering. So when I was back in school days, I was working for Dad in the holidays and did a bit of building and got my roots into that. And then when I left school, went to work for Motueka Lumber, who's a timber processing factory. So that was fence pickets and finger jointed mouldings into Australia and a bit of laminating. And then in 2002, I had the opportunity from Motueka Lumber to manufacture a couple of products for them.
Right.
So that was a really good stepstone for me.
So you set up your own
little entity,
little manufacturing business.
Yeah. It started off with one planer, 2 staff,
right,
and a snip saw. And, every day was a grind. But started off with that, and really I kind of wanted to have my own product, and that frustrated me. Just making a product for someone else, and there was nothing I could call my own.
Yeah, right. Yep.
So anyway, I went to the merchants actually, and the question I asked them was, what do you want that you haven't got? And the answer came out eventually. It was a laminated H5 post that could go in the ground that didn't twist.
Right.
And it took it from there.
Yeah. I can. So how long ago would that have been?
So that was 2004.
Yeah. So I remember there was somebody doing it earlier, because I remember in the late 90s having that same issue, and trying to get hold of them was a real challenge.
Yeah.
So the standard post was like a 125 by 125 solid, which 90% of the time would twist, and getting hold of a decent laminated product at a decent price was pretty challenging. So that was the starting product. Was that how long was that your only product for?
That took us like 16 months to get it sorted.
Okay.
So we had to work on the glue we're going to use, where in the log the timber was going to come from, because different parts of the log react differently.
Okay.
So there's a few nuances we had to get through before we had the perfect product. And that took us 16 months. And I guess that would have been our only product for probably our own product for probably 2 years.
And so you were sort of funding your business through making the other things that you were doing for Motueka Timber, or Motueka Lumber.
Yep.
And you were using the funds from that to bootstrap your way through developing this other product?
Yeah, exactly. And it was, innovation for me, it was an amazing journey. Like you could get put off by so many things so many times, but really it was to have the grit and the determination, I guess, to keep pushing through and until you had something light at the end of the tunnel.
So what sort of equipment was, back in those days, did you need to be able to make these H5 posts? Yeah,
so it's a four-sider, so that would dress the timber.
So that's a planer that planes 4 sides?
4 sides, yep.
For non-timber industry people?
Yeah. And then a glue spreader. So for a start, we're mixing glue in buckets and rolling it on with the roller. And then we had a glue spreader that squirted the glue on after the 4-sider. And then we made up a laminating press, which I copied one from Motueka Lumber. And so you hand lay up your laminates, you put a big long bolt across the top, do another layer, and then you rack it up with a torque wrench.
Right.
And that was another interesting thing, getting the right torque right.
Yeah.
And the right procedure for that. So there's a process of which bolts we did up first and which we did last to keep stuff straight.
That's what would happen if things went wrong. So what were your sort of lessons of, as you were working through that, what sort of things happened?
Lots of things went wrong, but we got things right in the end. But like delamination is obviously the worst one we can have. So getting the right glue for in-ground use was critical on that. And then the machining, the quality of your machining had to be perfect. Like you got a certain pitch mark you're allowed when you're laminating.
Okay.
And then the pressure that you put onto the timber when you're clamping it up.
Because if it's too much, I guess it forces all the glue out.
Yeah.
Okay. And not enough, it ends up being too thick a glue. And
correct. Yep.
Or doesn't stick.
And then temperature, because if you have the wrong temperature, your glue won't dry. And because if it's too cold and your glue doesn't dry in a certain time, then it will soak into the timber and again leave no glue in the joint. So there's a few things you have to control.
A whole lot of things to juggle and balance.
Yeah.
So how did you go through the process of sort of figuring out what the sweet spot was, what the ideal combination?
Yeah, well, we did have Scion, so I did use them a lot, and it's really good having an industry like that you can lean on. I think they actually need more funding to help us further for innovation. But yeah, that's probably my first call for advice was them. And then because we were manufacturing to the New Zealand standard, you had auditors that were coming around auditing you, so you'd lean on them as well. And so our set of standards, New Zealand standards, 1328, that has specific rules in there of what you've got to do for...
So the standard for glue laminated products?
Correct, yes.
Okay.
Yeah.
Yep.
Yeah, so a combination of having good advice from industry bodies like Scion, and then the New Zealand standards was helpful, and then looking up research papers.
Right. And what sort of research papers were they, and where were they coming from?
They'll come from universities.
Right.
So the Auckland University here has done a lot of work around glues. So we had to end up using resourcinal glue for our H5 post, and that was the only way we could get a code mark on our posts, and we're the only ones in New Zealand with a code mark on our laminated H5 post. So
were other people using resourcinol as a glue?
Yes, yep. There are others, not many. Quite a few of them have moved away to a PUR, polyurethane. We still think resourcinol is the best of the best. It's been around for 80 years. It's been used in boat building for a lot of years. So the likes of Scion and brands who gave us our code mark have got a lot of trust in it.
Right. And so what sort of testing processes did you have to go through? Because obviously it's a structural product, so it can't fall down. It's not about just looking good. It's got to be strong. So what sort of test scenarios did you go through? And I guess sort of a durability test, like how did you establish how long it was going to hang together for?
Yeah, it's a good question. So again, in the standards, it's got a durability test that we have to do. So it's called the autoclave test. So you have to, we take 3 samples out of every 10 cube we do every day, and we put it in an autoclave, which is soaking it in water, then drying it, soaking it in water, drying it again, and then looking for DLAM on that sample piece. So there's a specific amount of DLAM you're allowed, and if you're over that, well, you're out of spec. So then you've got to test another sample out of that same batch to get yourself back in.
And if that sample test's okay, the batch is okay. But if it fails, then you've got to write the whole batch off.
Yeah.
And so when you were starting off, I'm guessing you had a fair few failures while you were...
Yeah, we did. No, definitely. We had failures for sure. And yeah, so it was when we started nailing down, but every time you had a failure, you had an opportunity to learn something as well. So we just build on that. Every time we have a failure, we learn, and then we push forward and find out, we learn something more, and we can go forward from that.
Right. So in those early days then, it must have been quite a lot of investment going into it. How were you able to make it sort of stack up and carry you through that sort of initial phase where you've got this product idea, you're obviously pretty confident it's going to work, you've talked to some clients. How did you make the numbers stack up until you got some volume going through? Yeah,
it was really hard, but we had good business mentors that were helping me out. My father-in-law actually helped me out with a loan for a bit. So yeah, it's been family that have helped us, and good friends and industry bodies not so much. We have since then got some funding from industry bodies for innovation.
The Callaghan?
Yep. Right. And we got the tax credit this year.
Right.
So that was good to get.
It definitely helps. Yeah, I'm the same.
Yeah.
Yeah, unfortunately Callaghan's no more. So so that's definitely been a big part for us, as we've had quite a bit of support from Callaghan over the decades I've been at this.
Yeah.
And it certainly helped us move things along. So what's going to happen to the R&D landscape?
Yeah, I've still got the contacts, and I still use them.
Yeah, right.
So it's good, and I've got good contacts in Scion.
Yeah.
So, and even Scion, you wonder how long the funding's going to stay in there, but it needs to be there if we want the timber industry to go forward, and instead of just being a primary sector, be a secondary sector. We need innovation, and we need people, industry bodies to help us.
Yeah. So with the products you're making, then the raw material, the blanks, I guess that were coming in, that you were foresighting, were you producing those yourself, or were you outsourcing them?
No, outsourcing then. So we were just remanufacturing, as they call it,
right?
Back then, and so it was first the H5 post, and then architects said, "Oh, well, can you do laminated beams as well?" So we got into doing beams, and what really frustrated me about that was back then, if an architect wanted a beam, they'd say, go to engineers, say, I want a beam to span this and with this roof load, and you tell me what it is, and the engineer would do his calculation and come back with a beam size of 133 by 117 or something weird, size, and so I was making one of this and one of that.
Yeah, right.
Which that didn't work.
Was there much of a difference in the manufacturing process between the beams and the columns?
No, pretty much the same. Yep, same glue. We just used the same glue. We could have gone to a MUF glue for beams because they're not going in the ground, but we just stuck with the same resorptional glue all the way through.
I guess the glue cost is a relatively small component.
Yeah, it is. Yep, it's timber and labour, then a big glue. Yep. But so to get around that problem, I went to an engineer in Nelson, Tasman Consultant Engineers, and asked them to do me a set of span tables which match standard size timber.
Right.
And we gave that to architects, so now they could specify these beams that were standard sizes and a match standard timber. So if the standard timber wouldn't work, SG8
as in length or
SG8.
Structure? Okay, yeah.
If that didn't work, then they could put a Prolam in there and they had something that would work.
Okay, yeah.
And that started getting a lot more specification coming through and the right size beam. So then we could pre-make beams, have them in stock and get them out.
Well, how do you handle length? Because obviously beams vary.
Yeah, that was a challenge. So we've now got we stock everything in 6 metre lengths as blanks, and then we finger joint to whatever length we need on the day.
Oh, okay. So you can do a 12 by butting 2 6s together?
Yeah.
Sort of thing?
So it's a continuous. So everything comes in 6 metres now because our treatment plant's 12 metres, our kilns are 6 metres, and then we just re-finger joint it on the day, and we might be doing 6 metres together and ending up with 3 6s. But we just continuously put them through, chop them off at 3 6 or 4 2 or 12 metres or 18 metres.
And so the blanks you're stocking are the bits of timber that go into the glued beam, or you're stocking? Yeah, okay.
Yeah.
And so it's not like you're taking a big beam and finger joining.
No, no.
I was wondering how that would work. Yeah. So it's all the little bits are finger jointed, and the finger joints, I guess, are staggered.
Yes, correct.
Throughout it. Yeah. So what sort of maximum length can you make to now?
18 metres. Yeah. We've got a few plans to get to 20 metres probably end of next year.
Okay.
Yeah.
And what sort of other dimensions, so height and thickness?
Well, the biggest we've done, I think, is like an 800 by 220.
Right.
Again, that's fairly small in the scope of things. Like you go to Europe and they're making beams there, 2 metres high and 500 wide.
Yeah, I remember working on a building years ago where there was it was like a 35 metre span or something, and it was they would have been like 1.5 metres deep or something.
Yeah.
Tapered. Yeah, they were massive.
Yeah.
So glue lam's been around, but I guess what you're bringing to it that's different is they were sort of quite bespoke and I guess quite expensive, and so targeted more to specific applications where other things wouldn't work, whereas you're trying to bring a more of a production mentality to it and I guess try and make it more cost competitive.
Correct, yes. Yep. And so our sweet spot is in residential and light commercial, but these is a piece of market, those big commercial projects, those big CLT buildings that are going up around New Zealand. There's definitely a market there, and our plan is to get into that market probably in the next 3 years, like just to spread our base so we're not totally reliant on the residential sector when it falls flat like it has in the last year.
Yeah, last couple of years. Yeah. So your product range now is primarily the posts.
Yep, posts.
H5 posts and then beams. Is it what else do you do?
Yeah, well, so there was a stage when we were importing timber out of Australia and we're making what we called a PL17. So they had an MOE of 17,000.
Okay. So there was imported pine from Aussie.
Yeah, Pinus.
So you bring them in as blanks.
Yeah, different species. So it's Pinus aliotti, which is very, very stiff. It's grown up north of Brisbane. But they had to change their species because it was so stiff that when they had the hurricanes there, they'd snap. They had no ductility. So they changed their species. And so when we bring the timber in, slowly the recovery we got out of it got less and less until we're only getting 10% of the volume was making the grade. So we had to ditch the 17 and come up with something else. And so we dreamt up this idea. Well, we didn't dream it up, it's been there for years, but we started laminating a piece of steel in the top and bottom of the beam.
Okay.
Because
it's not like a flitch beam where they nail it through in the middle.
No, because that's, in one sense, that's very inefficient. Like a steel I-beam is the most efficient way you can use steel with a piece of steel on its flat top and bottom. The steel web in the middle is doing
just
nothing.
keeps the flanges apart.
So it keeps tension and compression fields apart. So copied the same process, put it into a beam, and so now the beauty of that is that we can use SG6 timber, so like pallet grade timber,
right?
Laminate the steel top and bottom and turn it into SG20.
Oh, right. Okay.
So that's the highest structural timber beam available.
So what was the thought process getting from, okay, we can't get this 17 anymore? How did you get to that idea?
Yeah. Well, yeah, again, probably asking that same question, and that came about asking that same question, what do you want that you can't get? So we developed this market, then all of a sudden we're going to turn it off, and it's going to hack a lot of people off.
Yeah, right.
They got used to specifying these smaller beams that they could put over garage doors, and so you still get your roof rack on your car in there.
Yeah.
And all of a sudden it wasn't going to be there. So, yeah, it did take a wee while. We went to Argentine because what I thought, if we had the same species on the same latitude in the world, we'd get the same density. That came
That's lateral thinking, actually.
that came from Scion. And anyway, so we went over there with my father-in-law and trotted around Argentine for a week, went bush and took our testing gear over there. We kind of had this 20-kilo weight we're putting on bits of timber and calculating the deflection and they couldn't find it there either.
Yeah, right. Okay.
And I rang up an old guy that used to live in Chile, and he said there's only one place on one mountain that you'll get it, so higher up. And so the problem was that the topsoil over there was so deep, these trees were just growing 10 times as fast as the ones in Aussie. Go to an Aussie tree, and it'll be about 200 mils round and 30 years old, whereas these trees in Argentine were 18 years old and 400 round.
Yeah, but low density.
Yeah, low density. Yeah. So that didn't work. So back to the drawing board, and I got onto this steel idea and thought, how can we make this work?
So how do you connect the steel to the timber?
Epoxy.
Right. Okay.
Yep. So 2-pot epoxy. So yeah, it does a really great job, and we totally encapsulate the steel, so we don't get any rust happening in the steel. And
So is it you'd like sort of got a groove inside the timber, or?
Yep. So we just groove the top and bottom of the timber beam, and then fill it up with glue, put the steel in, put glue over top of the steel, hold it down there with a few nails.
Yeah.
Let it dry overnight, tip it over, do the other side. Away you go.
So what sort of testing did you have to go through? Because obviously now you're a much greater structural performance than what you were doing before. So how did you make sure it didn't fall apart?
Yeah, well, again, we had to go through that qualification testing that we have to do at Scion. So they did all that for us. So we had to do 30 beams and then take the average of those as our structural grade. And then we had to do delamination tests on it and weathering tests. So the weathering is probably more in our interest. So what we want to find out is if the beam's in a construction site for 3 months, 6 months, not covered in, what's it going to do? Like theoretically, it should be covered. Normally speaking, it would be covered in 2 or 3 weeks and get the roof on. But so we just
sometimes things happen.
So we're just trying to understand that. But the funny thing is, when you're testing it now, it's actually deflecting up and down in the weather. So we put two 500-kilo weights on it.
Yeah.
It deflected, I forget what it was, 5.2 millimeters or something. And then in the wet, it's actually going back up.
Okay. Was that the wood swelling? Or?
Yeah, well, we don't know. But really interesting to.
Yeah.
So we're going to leave that there for a year and see how that fares out.
So when it comes to the strength of the product itself, so I presume you can't test the beam itself. So you stress grading or something like that, the individual boards that go into it, and from that, then that adds up to the performance of the beam as a total. Yeah,
and we do. Yeah, exactly right. So we test the timber going into it, and then we know what the steel tension is, and then we do. So we've got to do continuous testing now, which we can do on our beam tester. So we'll test what is it? 1 beam out of 30.
Okay, so you can actually test the full
so
beam.
you do a 4-point test load on it.
Okay,
and crank it up
and the load's obviously going to be relative to the size of the beam. So what sort
correct.
of
so
size beam can you test?
Basically trying to deflect it about 15 millimeters.
Right. And that's on your 800 deep?
No, so the biggest we do on that PLX 20 product is 290.
Okay, yeah.
So it's not a huge beam.
So within the realms of possibility.
Yeah.
So this SG6 timber then that goes into it, where are you getting that from? Where does it come from?
Well, we're actually getting it from our own mill now.
Okay.
So yeah, we've got
you didn't buy your old boss, did you?
No, we didn't. No, so that came about in end of 22. We just couldn't get enough timber when the construction market was just going absolutely nuts. Couldn't get enough timber. The board said, okay, well, we had brought a site in 2017 and closed the mill down because we didn't want to be sawmilling. We just didn't think that was our gig. Anyway, 22 came along. We couldn't get enough timber for love nor money. So the board said, "Oh, how about you get your mill going?" And so we got a little bandsaw, Woodmeyer's bandsaw mill to test our concept.
So you didn't use the old plant? Yeah.
Not initially. So we got because again we were cutting a specific size, again to reduce the amount of waste.
Yeah.
Because when you laminate standard size timber like 50 mil timber, it's actually the wrong, because you got extra processing when you're machining.
You end up with too fat.
Yeah, you get too fat.
So you'd be a 42 or...
Oh, we've gone to a 55.
Okay. Oh, right. The other way. Okay.
Other way. So we've got less glue lines.
Yeah, makes sense.
So anyway, we had this little Woodmeyer's mill going for a year, and then scoped out, get the old mill going. And that took us 2 years to 18 months, I think it was, to get it up and going. So now we're cutting our own timber.
All right.
And so then we had another problem was the core wood, which is in the centre of the log.
Yeah.
Like export market, you're getting probably $330 a cube for it. That's not that crash hot. Again, so that low grade lumber now can go into a PLX 20.
All right.
And soak some of that product up.
Okay.
Yeah.
So the outer wood goes into the normal glulam beams.
Yep.
And then the PLX 20 allows you to use the
low grade.
Low grade.
Yeah.
That's pretty cunning.
Yeah.
So what sort of recoveries do you get out of a log then?
Yeah, well, we're saw mining a bit different from most.
Yeah.
We're kind of more off the American model where they do random width cutting.
Okay.
So we're using that random width where the log rolls off into a beehive component actually, which is a bit random, but that kind of soaks up, again, that waste. And then on the outside of the log, you'll get your best structural timber on the very outside of the log. So that's where we get our SG12 or PL12 product. Then as you go further in, you get your PL8, and then you get into your SG6, which we whack into the PLX 20.
Yeah, right. And then dimensionally, you'd have like standard widths that you aim for, or how do you deal with that?
Yes. So
you wouldn't be doing that many different widths if you're trying to fit with conventional framing? No.
So basically we're doing, 90 mil and a 112 and a 135.
Right.
So when we're cutting the flitch, the other thing I was thinking with the flitch, we can just have one size of flitch in stock, 55 mil, and then we can edge it on the day when we
suit
whatever we need.
Yeah,
so if we want 70 mil or 100 mil or 125 or 150.
Where does the 112 go? What sort of?
That 112, that's a laminated post.
Okay.
Yep.
Oh, yeah, of course. Yeah.
So you get a 4 inch, 5 inch, and 6 inch.
Yeah, right.
And 8 inch, and now up to 10 inch.
Yeah, okay.
Yeah.
Okay.
Keeps on going.
Yeah, because I know, going back to my Carter Holt days, that was one of the challenges of the mill was basically trying to cut it up in the most efficient way. And one of the things I was working with was sort of trying to rationalise the product range. So it was really easy to optimise it to the nth degree and end up with all these funny sizes and grades out of it. But if you didn't have a market for them, all you did was build up stock of it.
Yeah, exactly.
And so there was a trade-off between a lower recovery but product you could actually sell versus a higher recovery and not being able to get rid of it or struggling to get rid of it.
Yeah.
So it's a bit of a juggling act in that sawmill optimization.
It is a juggling act. And so we're actually looking at more products we can do in the PLX 20 kind of realm.
Right.
And it's an efficient way to use timber and steel. So you're getting the best of both worlds.
Yeah, you're basically using them for where their optimum performance is going to be.
Yep.
Yeah.
Yeah.
I didn't. So I was aware of the PLX and sort of realised that was a combination of steel and timber, but I have to admit I didn't really pay that much attention as to exactly what. So it's really interesting that you've ended up with that.
Yeah. And so that's kind of morphed into the next product, which was a PLX portal, we call it. So that came again from going around builders, and they, what do they want that they can't get? And they said, well, how can you take the steel out of our residential builds? And you'd see steel portals here, then everywhere. So that morphed out of the PLX 20, and then we put some PL12 columns each side, and then now we've got threaded rods going through and with a dovetail connection onto the steel and pulling that tight to get a moment joint on our knees.
Right, okay, yeah.
And that's quite an exciting.
So you're actually achieving some bracing out of the portal?
Yes, correct, yeah.
Right.
So,
which is obviously what steel can do.
Yes.
Sort of, yeah.
Yeah, and then at the Buildings Ed show last year, we had our portal display there, and a couple of architects and engineer came past and said, oh, can we just have the column, get us some bracing units out of just using a column? And they said, okay, if you could get a 400 by 90, giving us 100 bracing units, it would be really useful.
Yeah, okay.
And we could just dot it around the house where a piece of jib wouldn't do the job.
Yeah, because they need a minimum 600, I think it is.
Yeah, yep.
Jib brace.
Yep, and to get any decent bracing, they need a full sheet 1.2.
Yeah.
So anyway, that again took us into the innovation pipeline and what can we do here, boys? And so anyway, we ended up turning out the Pelix 20 beam on its end and welding the steel to our foot bracket that anchors into the concrete, and we ended up getting 131 bracing units out of it.
Out of a 400?
490, yeah. But again, that took iterations of testing, right?
Yeah.
You never get it, well, sometimes you might get it right first time. We never have. But we were testing that at Scion actually, and we broke their testing machine. Not because it was so stiff, it just had a hiccup and it took it out. And so we did get some pricing off someone else to do some testing for us, and it was quite a hefty price. And we thought, bigger this, why don't we just build our own testing lab? So now we've got the Pro Lab, so we can test stuff in there all day, every day.
Okay.
And iterate very quickly. To come up with a product
at a relatively low
cost.
Yeah. So what sort of gear have you got in the test lab then?
Well, just some big steel beams basically in a rectangle, an L.
Yep.
And then, so one side we anchor in our portal, and then the other side we have just a hydraulic ram that pushes the thing sideways, and it calculates, how much we're pushing and then what pressure we need to push that.
Yeah.
And comes up with, it's a P21 methodology, which is the brand's process for testing for bracing. So just same testing procedure they use for brace line for jib.
Right. Are you able to test other ideas using that same gear?
Yep. No, we've had the SIPS guys want to do some testing on there. So.
Right.
Yep.
Yeah, if you've got the gear there,
might as well use it.
Might as well make use of it. Yeah.
And then you're always learning, right? We've put extra transducers over against what they had at Scion on the portal base fixings. So now we know how many kilonewton is getting yanked on the bolts that are going into the concrete.
Right.
Because the column had such a high load into the concrete. I think it's ended up being like 75 kilonewtons. So that meant...
Which sounds like about that much.
Yeah, which is a hang of a lot. So it meant normal foundation reinforcing wasn't enough. So then we had to design a
detail to go with it. Yeah.
Yeah.
Is that for the standard bracing one, or is that to push it even further?
That's for the column. Yes.
Right.
The portal doesn't need it because most of the work in the portal's in the knee joint.
Yeah, right.
Not in the concrete.
Yeah. And with the portal, what sort of spans can you achieve with it?
We've gone out to 6.6 metres.
Which is a decent size gear.
Decent size, yeah. That's plenty. But again, engineers are asking us, can we go to a commercial building with it?
Yeah.
Or like a 12 by 12 office apartment or...
Yeah.
So, there's plenty more scope yet to keep going.
Yeah. So, it sounds like you've obviously had a lot of experience now with innovating and developing new products. So, have you developed like an internal process for that you go through with new ideas and new products?
Yeah, we've had to do that. My son put it in place for me, actually, just to slow me down a bit.
Yeah.
But it was good. So we've now got an innovation pipeline process that we go through. So everything's got to be loaded in there. So, and that's to make sure we're putting out a product that's going to be fit for purpose and is actually going to save some pain points in the industry and make us some money along the way. So that's a process we go through. So it involves a team of about 5 of us, and there's steps and gates we've got to get through at each stage before we can start pursuing the next, going through the next stage.
And so the initial bit of it is coming up with the idea, and it sounds like a lot of that's come from just being in the market, asking questions, listening for opportunities.
Yeah, definitely.
So if you get a sniff of an opportunity, what's the sort of first thing you do with it?
Well, that's probably my main role now, is to get out there and just talk to people, and you'll always learn something from everything. And we go to a lot of conferences now, and we always pick up something from them. You've got your product there. Someone will be looking at it and say, hey, what about this? What about this? And that's when the first seed of something comes through.
Yeah.
And makes you think about, really comes back to our purpose is building better together.
Yeah.
And that's what we want to do. So, you ask questions, it's very similar to what do you want that you can't get, is how can we build better together?
Yeah, right. Yeah. And so then once you've got that idea, sort of what's the next step in your process? And I'm not expecting you to give away your IP, so if you can talk generally, I guess, about
So that goes into the innovation pipeline. We have a meeting on that every week, And then, so we've got to scope out the market.
And how do you go about doing that? Because that's always a bit of a challenge, is how many people are going to think the same way as I think.
Yeah. That is hard. So that'll be going to engineers and architects. Here's a product, and builders. So it's got to solve problems for all those three people.
Yeah.
It's got to be easy to specify. It's got to make it easier for the builders. It's got to give the homeowner at the end of the day a better house.
Yeah.
It's got to be easy to specify, and it's got to be easy for the merchants to stock. So all those things are got to be thought of. And
so you basically test the idea against each of those as part of your pipeline process?
Yes. Yep. And then it comes into design. So how can we do a model the design in software first to say, okay, does it
work?
Yeah, does it work? Is it achievable?
Yeah.
Is it? And then we could do a rough back costing on the product. So is it going to fit the market for costing?
Yeah.
And then once you've passed that, then we can start doing some testing. And then it just rolls pretty fast from there.
Yeah, right.
We can be testing, we can test something 3 times a day.
Okay.
The same thing, and this bracket here is failing here. Okay, change the bracket, weld it up, get it back on there. Let's go again.
So what do you think, what would you typically be achieving now from sort of that initial idea through to something that you're basically getting out into the market? What sort of timeline would you be taking?
I think the column took us 9 months.
Yeah, that's pretty good. Yeah.
And then, because another one was one of the engineers wanted a portal that could give them 400 bracing units. And I thought that would take us 3 years to get through that. And that was using Scion's machine.
Right.
And it broke down at the start of that process. So we had our own rig in there, and we had the results. Like, we haven't put it to market yet, but we had the results that proved that it did 485 bracing units in 3 months.
Right.
And that's just because we could iterate every day, or more than once a day. We could change something and try it again, change it and try it again, and move very quick.
So once you've got a product, so you've figured out, you've got an idea, you see there's a market for it, you've done a bit of work to satisfy yourself that it stacks up, that the market's big enough versus the cost. How do you get people finding out about it? How do you get it out there? Yeah,
well, that's always a challenge, and it's always hard to get people to change, isn't it?
Yeah.
They love just doing what they've always done, and if something's not broken, why change it? Even if it's better. So that really relies on our marketing team. So they're doing a really great job for us. My son Berkeley's heading that up. So it's about getting really good, clear documentation. You've got to get trust to the engineers. They're probably the ones that love asking all the difficult questions, like, have you tested this? Have you tested that? So we're getting way, way better at that now.
Right.
And so the column, I think, is going to be a good example. It's only been in the market for 6 weeks. We've already had our first order. We've already had plans come through of 7 of them specified in there. And that just went out with an email. Went on LinkedIn. We've got a good database of architects, engineers, specifiers, and then we have part of the innovation process I didn't say was we've got a group of about 5 engineers that we run all our ideas past.
Team engineers.
Yeah. And they love it too, because they kind of feed into it, and I help them develop that thing, and so you get early adopters, like that. And then it's the same with the builders as well, and the architects. Like, you get some good friendly ones of those. Hey, this is an idea. What do you think?
Yeah.
And that's one of the proof points that we need to get through.
Yeah. And then it's just getting out there, so the trade shows and all that sort of stuff.
Yep.
Yeah. Just trying to make people aware of it.
Yes. Yeah. And with our specifier, if we can get a product into our specifier, that's a good thing as well, because architects can see it in the specifier. Hey, this is a new option I can specify here. And
specifier that
we've got our own Prolam specifier, so architects can use that to specify beams and get a PS1 without having to go to an engineer.
So as long as it fits within the criteria of that.
Yes. So again, it's built for residential and light commercial.
Yeah, right.
But we've got over 6,000 people registered on there.
Okay, right. That's a pretty good user base.
That's good, yeah.
So with your product then, sort of what portion of it would be specified by architects versus engineers designing it in?
Probably on the Prolam, the posts and beam part of it, and the PLX20, I'd say probably 70% would be architects.
Right.
But when it comes to bracing, especially bracing that's outside the standard, that generally goes to engineers.
Getting into challenging bracing situations.
Yes. Yeah. And so the architect will say, I can't figure this out, and throw that at the engineer. So I'm thinking the column and the portal will be probably 30% architects and 70% engineers.
Right, the other way around.
So a different mix.
Yeah. So a different communication strategy, or?
Yeah, it is. And we've learned a lot on that. Like, that's where we got the challenging questions on the portal. The main one was our fixings into the concrete. So we actually we built our own test pads of concrete.
Right.
So we did 60 metres of 3604 flooring, 60 metres of rib raft, and 60 metres of concrete block foundation.
Yeah.
And there was anchors and pulling them out and trying to figure out what we're doing. And because part of that problem was with insulated slabs now, you have to get your anchors away from the edge of the concrete.
Yeah.
So the new brackets actually got angled, inclined anchors.
Okay.
So that gets it away in both directions. So you could have that portal on the very corner of the concrete and it's angling in away from both corners. And that no one's kind of developed that. And so that is pretty new technology. So we had to work out what angle was the best angle. And that was a tough one to figure out.
Yeah.
But we did it.
Yeah. So it sounds like you've put a fair amount of resource into the whole R&D process.
Yeah, we have.
Are you willing to share a percentage of what your turnover is that you spend on R&D?
It's probably 3%.
Okay. Yep. That's affordable, but it's pretty, by New Zealand standards, it's pretty significant.
Yeah.
So obviously that allows you to do a lot of these things that you're doing with your innovation process. So coming back to sort of the beginning then, so it started off with you remanufacturing a few little things. So how many people did you have in your team then?
It was just myself and 2 others.
You and 2 others, and now what's the team look like?
About 105.
So your roles obviously changed quite a bit over that time. So what does your day look like now compared to, say, what it did back in those days?
Back in those days, it was feeding and praying all day. At the end of the day, writing down how much money I made. But so now it's probably more around strategy and innovation and getting amongst customers and going around the shows.
Right.
And the customers being more, I do merchants, so I keep going in there, but it's probably more around architects and engineers.
Right.
Trying to solve their problems. But it's strategy, because the equipment we need now is a lot bigger and faster than it used to be back then. So you've got to have a plan for that. You've got to be planning that out 3 to 5 years in front of you.
Yeah.
Because the worst thing we can have is if the market is going to come back. So when the market comes back, we want to be ready for it.
Yeah.
And we want to still have 30% capacity up our sleeve, because if anything else bumps along, we can grab it.
You don't have to answer this, but how you fund the business? So what? Because obviously there's a fair bit of investment going on to it. Have you been able to do it from cash flow, or have you needed external investment?
Yeah, mostly cash flow. So I'm still the sole director.
Okay.
And so the banks are good. We bank with ANZ and Westpac, so we run 2 together, and so you can run one against the other, and I think that's a good strategy. We're not going to go away from that. And then in the innovation tax credit, that's right. That's good. The other one is what's that new the wood processors growth fund.
Oh right, yeah.
That's one we haven't used that yet, but that is something we could use. Yep. And I think there needs to be more of that if New Zealand wants to bring timber to life and again, what I said before, take timber from being a primary sector to a secondary one. Yeah. It's going to have to unfairly, in one sense, fund that sector. Yeah. To give it the guts and the backing to do something different. Yeah,
and I guess coming back to my opening remarks is that we're a relatively small country. The industry is made up of relatively small businesses. So while you manufacturers are much bigger businesses than we are, in the world scale, you're still pretty small. And
totally.
we're trying to do things to compete against the rest of the world. So sometimes there is the need for a helping hand from government to be able to make that sort of stuff happen.
Exactly. Like you go through laminating plants in Europe. There's a plant there we went through. They're doing 300 cubic metres in an 8-hour shift with 8 people. We're doing 47 cube in an 8-hour shift with 40 people.
Right.
That part of the business.
Yeah. And the difference would be capital investment.
I guess. Totally. Yeah. And market size. So we've got the other problem is we've got a very small market size. So unless you're and we're basically kept out of the global markets because these guys in Europe with all the capital, we can't compete at all.
Yeah. So what about freight? So how you're obviously based in Motueka.
Yes.
you're shipping all over the country. So how do you make that viable?
Well, it's got that is quite an awesome place to be, actually, because all the trucks are backloading back up to Auckland.
Oh, okay.
So our freight rate to Auckland is cheap comparatively, and that's a big market.
Okay.
So again, we're in a little bit of a sweet spot being where we are. Okay, the water's challenging sometimes.
Yeah.
But apart from that, no, we've got...
And the wind might be today.
Yeah.
Flying home.
Yeah. No, so we have got a pretty favourable freight rates, actually.
And I guess, you'd have a stable workforce. There's wood nearby in terms of trees for your raw material. So
yes,
there's a bit of a sweet spot, really.
It is. Yeah, there's plenty of trees here. We need, I think, calculated the other day, we need 3,500 hectares of trees to be self-sufficient.
Okay.
So we've got 72 hectares, but yeah.
You actually own your own trees?
Yeah, we do, yeah.
Okay.
Yeah. Just a little block up the back.
All right.
Yeah.
So, and you guess source the rest
in
the local market. There'd be more than 3,500 in the region.
Yeah, totally. Yeah, it's a massive forest, and sadly, most of it goes export.
Yeah, as logs.
Logs,
Low value. Yeah. So you're doing exactly what successive governments had said we should be doing, but it doesn't sound like it's been an easy journey. It's you've taken a lot of risks yourself personally, and certainly looks like you, and it sounds like you put your heart and soul into it.
Yeah, no, totally. And it hasn't been easy, but it's been fascinating and challenging. Like, I've always loved a challenge. So keep bringing it on.
That's great. Well, thanks, John. Thanks for your time today. It's been fascinating for me, and hopefully everybody doesn't mind me geeking out a bit on the engineering side and the wood side of things. So it's been a great discussion for me, and hopefully other people are interested as well. So thanks for listening. If you need a QS that gets involved in these sort of things and really understands the details about how buildings go together, and you want to understand more about your costs, or you've got a product, you want to understand how it fits in, and otherwise, if you want to talk to somebody that's innovating in the wood space, then get in touch with John from Prolam.